what's there in this demo. So you can see that there are two sides. There's where my cursor is. This is the left side of the application, and this is the time domain. So you can see here is milliseconds, all of them. So these four panels show four different waveforms. And basically, we will describe exactly which one is. First is the input signal. So suppose it's a sine wave here, right? A sinusoidal, so a sine in this case. And when I load the application, it comes with a preloaded, predefined frequency. Here is 100 Hertz. So of course, I can change this frequency up. So I'm making it turn faster. Remember this exponential turning in the unit circle, right? So turning faster, faster, faster. Now I go the other way around, turning slower, slower, slower. The frequency appears here, and I can play actually the signal, right? So it goes to 0, and 0 you basically see a line because it's DC. So let's continue, stay at, for instance, here 300 Hertz. 400 Hertz almost. So actually, I can actually type the values. If I want 300 Hertz, I just press and go here, update. Then it goes to 300 Hertz. So this is the first top panel. The second panel is my sampling signal. So it's basically representing this train of pulses with a given sampling frequency. So what's the sampling frequency there? It preloads with 48 kilohertz. So it's pretty high. So I can obviously, to see effects of sampling, critical sampling, etc., I will go down. And you see that this has a bit more discretized. I mean, you can put continuous values, but sometimes it goes closer to certain values because just a linear scale with so many values makes it harder. So here again, look at this second panel. The first obviously doesn't change because my input signal is still at 300 Hertz. Now I'm changing the frequency, sampling frequency. So basically the lower the sampling frequency here, going to the left with the slider, basically the spacing, the sampling period increases, right? And the spacing of this train of pulses increases. Means I'm taking less samples per period. And actually this is exactly the third panel here on the left. This is basically a pulse amplitude modulation. So you have this train of pulses here, so pulse, being whose frequency is given by the sampling frequency, right? The period here is diverse. And the amplitudes are all one. So what you see on the third panel here is basically this initially equal amplitude train of pulses with this new amplitude being modulated by the signal I'm acquiring, so the input signal. So in this case is this 300 Hertz. So if you see here, this is the first period, this is the second period, that's part of the third period. And you can see that for 3000, here 6000 Hertz sampling frequency, and at 300 I will get 20 different samples in one period. So obviously, again, as the more I reduce the sampling frequency, the less samples I get per period, right? And then here in this application we made, the smallest sampling frequency we can add is 3000. So when I'm 3000, how many I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 6000 I have 20, 12,000 I have 40, etc., etc. So it's basically very easy to tell how many I have. So what do we see there? Again, input signal here on the left top panel, sampling signal, the train of pulses, second panel below the first. Third panel is the result of this sampling in the time domain. So again, left is time domain. So I see basically this same train of pulses with the amplitudes now modulated by the original signal. So of course now if I increase the original signal, you will see that these amplitudes here will change, and I will have less and less, obviously increasing the input signal. It's similar effect as decreasing, keeping the input signal constant frequency and decreasing the sampling frequency. I have less samples per period. So on the fourth panel here is the reconstructed signal. So what's going on here is I have a signal, it's entered this system, that's the sampling system with this characteristic. This is the output in the time domain. From this output, I reconstruct a signal that appears on the fourth panel, the bottom one on the left. So this reconstructed signal here, because my sampling rate, sampling frequency is 3000 Hertz, and my fundamental frequency is 800 Hertz, so less than half of the sampling rate, I get the same signal back in the output. So far so good.